Hi everybody, I'm Gray Stafford. Welcome to the first video version of our weekly Zoologic podcast. Zoologic is available on any of your favorite directories where you can listen on the go. And each week we try to bring you interesting scientists, best-selling authors, field biologists, zoo professionals, and even some celebrities to talk about animal-related issues, both those living in the wild and those living in our care at your favorite zoos and aquariums. This week we have a panel of experts to talk about some of their peer-reviewed research, but also to discuss the problems that can occur when opinion is passed off as peer-reviewed science. It's happened of late, and it causes a real problem because it creates a narrative that is false. So today we're going to try to correct that narrative by bringing you actual science and data. And I hope you enjoy the conversation. Without further ado, I'd like to introduce our first panelist. She is Kelly Jaakkola. She's the Director of Research for the Dolphin Research Center. She's also Chair of the Scientific Advisory Committee for the Alliance of Marine Mammal Parks and Aquariums. And she and our second guest today wrote a paper about dolphin life expectancy. So Kelly, take it away.
Okay, so can you see my screen okay?
Absolutely.
All right, so this question of how long bottlenose dolphins live in marine mammal parks and aquariums versus the wild has always been an important part of this debate about whether these animals should be kept in marine mammal facilities and how well they're doing. And this is because for any animal, including humans, survival rates and life expectancies are indicators of overall health and well-being. But the problem is, for a long time, we didn't have great current data. And without great data, what you'll sometimes see is that people will make things up, or they might repeat a number that they've heard somewhere, but they don't know the source, or they might use old data that may not be accurate anymore. So last year, my collaborator, Kevin Willis, and I published a paper where we analyzed the survival rates and life expectancies for all bottlenose dolphins in US facilities since 1974. And then we compared those data to the data from wild populations. And here's the upshot. What I'm showing you here is the survival rate for the only 3 wild populations for which we currently have that information. And when I say survival rate, what I mean is the survival rate is the percentage of a population that survives each year. So if 5% of a population die every year, then that population has a 95% survival rate. And the higher that survival rate is, the longer those animals are living. So the first thing I want you to notice here is that the wild is not all the same. There are some populations that are doing quite well with high survival rates. And then there are other populations where the survival rates are much lower. But for today, I want to just stick with the best case scenario. And I want to do that for 2 reasons. First, this is a population of wild dolphins from Sarasota, Florida, who have been well studied for several decades. So we know the data are good and solid. And second, of course, we want to set the bar high. When we're making these kinds of comparisons, we want to compare with the best situation there is. So let's do that. These green bars are the survival rate for bottlenose dolphins in US facilities over the past several decades. And what you can see is that 40 to 50 years ago, that's that first green bar on the left, survival rate in facilities wasn't as good as the best case scenario in the wild. Back then, almost all the dolphins in facilities were caught from the wild, which is presumably a really stressful process to go through. And facilities didn't know nearly as much as they do now about how to take care of dolphins. This was all new. But since that time, both of those things have changed. There have been no wild collections in the US for over 30 years. The last one was in 1989. And since then, facilities have learned a lot about how to care for these animals. So what you can see is that the survival rate has gotten progressively better until today, where the survival rate of bottlenose dolphins in US facilities is at least as good as the best case scenario from the wild, which means that dolphins in US facilities today are living as long or longer than wild dolphins. And that's what the data tell us. And that's it.
That's great. Thank you, Kelly. And To follow up with that in a way is your co-author from that paper, Kevin Willis. Kevin Willis is a longtime zoo professional. He is author of multiple publications on animal life expectancy from elephants to orcas. And I think it's fair to say, speaking on behalf of the entire zoo community, he's been one of our go-to guys in terms of statistics and probability for a very long time. So Kevin, welcome, and the floor is yours.
Thank you, Gray. Hello, everyone. I assume you've tuned into this podcast because you are interested in marine mammals and may be concerned about some of the things you've heard or read about marine mammals. For example, orca populations that might not be doing well, or that orcas don't do that well in zoos and aquariums. When you're looking for more information on this, you often find a confusing mix, and it can be very difficult to determine what actually the information is. You can see from my subtitle, what I'm going to talk about is where these different numbers come from. And I'm going to use a couple of examples. The first one is going to be on something you know the answer to, so you'll get an understanding of how numbers can be saying very different things. So let's start with this slide. This is what I'm talking about. I just Googled very simply, how long do orcas live? And you can see basically two answers. In the top, you can see females 29 years in captivity, males 17 years in captivity. And in the first website that comes up, I've highlighted what they've said. They survive on average less than 10 years. So 2 to 3 times difference between these two things that should be the same, right? Let's go to something we know a bit better. The Center for Disease Control puts out a report on deaths every year, takes a couple years, so 2017 is the most recent. Let's say you wanted to know which is the safest state to live in, all right? And so I've just picked a few states here, and I put in from the CDC report the number of deaths in each state. And if you look at those numbers, you might say, oh, well, Alaska, they had the fewest deaths, that must be the safest. But most of us know something about population sizes in US states, and compared to Florida, Texas, and California, there aren't many people in Alaska, so probably the low number of deaths is more related to the population size, right, than actually whether it's a safe place to live. These would be good numbers if you want to know, for example, how many hospitals you should have in each state, but it doesn't really tell you anything about safety. So in this next slide, I've put in the mortality rate, that is the number of deaths in 2017 in each state per 100,000 people. And you can see the order has changed quite a bit. California went from last up to second as far as having the lowest death rate. Florida, you can see, is dead last, pardon the pun. But there is something we know about Florida, and that is that when people retire, they often move to Florida. So the ages of the people in Florida might be quite a bit older, and if older people have a higher mortality rate, you would expect Florida to have an overall higher mortality rate. And this is also in the CDC report, and you can see everything's changed again. California has gone from the bottom to the top. Texas is now at the bottom, and Alaska is somewhere in the middle. All of these numbers are correct, right? They're correctly calculated, but the numbers are telling you different things. They're like different words. They have different meanings, and you need to make sure they're being used in the right way in order for you to be telling the truth and making sense. So let's go back to this. If you go to the Orca Network website and you do a little bit of reading, what you see is that they calculated their number based only on orcas that had died, right? Orcas live a long time. Orcas have only been in human care for a handful of decades. So at this point, of the animals that have died, you basically have juveniles that have died, so we're counting those. And all of the 40 and 50-year-old animals we're not counting, right? So of course you're going to get a low number. So although the average age of animals that have died is a valid number and can be used in some circumstances, it really doesn't tell us anything about how long the living animals are going to continue to live, right? So that's why these numbers are different. Presumably they're all calculated correctly, right? But they're telling us different things. So maybe you are a little skeptical of websites of organizations you don't know a lot about, and you'd much rather go to the scientific literature. But when you do that, you don't necessarily find a lot of consistency either. I picked two publications that came out in 2015. I'm going to call them A and B. Publication A is Captive Killer Whale Survival. And the second one, much longer title, was a comparison between captive killer whales and wild killer whales. All right. Both of these were peer-reviewed publications. Both had scientists review them and say, yes, these data and conclusions appear to be valid. But they had two very different outcomes when it came to what is the median age of survival. All right. Study A was 12.1 years. Study B was 28.8. So which one is right? Both of them? Neither of them? You have to look at what they actually did, just the way we did with the CDC data. Study A used data starting from birth because they were trying to estimate values for the population in US facilities. Study B used animals starting at 40 days of age, so they excluded the ones that died very young because they were comparing the captive population to the wild population. In the wild, calves are not typically seen until about 6 months of age. So in order to be a valid comparison in that study B, they needed to exclude those early deaths. So the numbers are different for a reason, because they're looking at different things. However, study A, in their discussion of their paper, decided to go on and make a comparison that was not valid. They compared their number for how long orcas live in US facilities to how long they live in the wild. And so in one study, they're using infant mortality, and the other study, they're not. So it's like just using different terms, different words. They don't go together. They're not comparable. It's not surprising that study A concluded that wild orcas live longer than the ones in US facilities, and study B didn't. The title of my final slide really is my take-home message. You really don't usually need a PhD to understand the results in papers, right? Read carefully. Is the question they're providing an answer to appropriate for the data they have, right? Are they comparing values? And if they are comparing them, are they equivalent data sets they're using? Are they equivalent methods they're using? And finally, and this is something Kelly and I found in our paper, if people are using data going back into the last century, 20, 30, 40 years ago, and mixing it all in together, it's probably not going to be a valid comparison, right? Because things change over time. We get better at what we do, and that should be acknowledged in the literature. So thank you. Hopefully that helps.
That was excellent, Kevin. Thank you so much. Really informative stuff. I think I learned more about statistics in 4 minutes than I learned in 5 years of graduate school. So thank you for that.
It wasn't even stats.
Shh. Don't give it away for me. Our next guest is Andreas Fahlman. Andreas is a researcher with Oceanographic Foundation in Valencia, and he particularly studies questions revolving around dolphin physiology, respirometry, energetics. And so, Andreas, welcome to the program and take it away.
Okay, thank you very much. My name is Andreas Fahlman, and I'm a comparative physiologist that studies animals and trying to understand physiological limitations to understand how man-made changes to the environment may affect their survival. So as I'm sure many of you know, respiratory disease is a big problem in marine mammals, both under human care and in wild animals. And it's difficult to diagnose, and it's both, many of the methods are invasive or they don't provide functional changes to the respiratory system. So for that reason, in around 2013, we teamed up with Dolphin Quest and with Siegfried and Roy's Secret Garden Habitat to develop lung function testing and spirometry testing in dolphins. We also use this to study how the lungs function in these animals as adaptations to diving. And for spirometry in humans, I'm sure that some of you have seen this or have done this when you go to the doctor or the pulmonologist. Basically what they're measuring, you see here flow on the y-axis, you see volume on the x-axis, And the pulmonologist then looks at these, and then they compare them, and they see shape changes with specific diseases. So then they look at these, they say, okay, you have emphysema, and they give specific treatments, and then they can follow up with time and then seeing how this is affecting the flow volume changes, the functional changes. So we did this in Dolphin and developed these tools in dolphins. Here you can see some data from a healthy dolphin, and then you can see how this is then changing in an animal with obstructive disease. So we've been able to show that this is actually a useful tool to assess functional changes in respiratory health. And what we're also trying to do is showing that this can, we can determine how treatment efficacy is affecting lung function. So here you see some data from an animal that was recovered from Vancouver Island. This is a false killer whale. And through time, he is recovering his respiratory capacity. You can see that both flow and volume is improving with time. We're also trying to provide these tools to stranding networks, so both the stranding network team and the veterinarians can assess functional changes in respiratory capacity through time, because the animals are laying on the beach. They're not used to having, you know, a ton or 500 kilograms of weight on their chest. So they can assess through time if animals are becoming worse, or they can determine if they have certain diseases and then select the ones that should be refloated, the ones without respiratory disease. So basically what my group and what I'm trying to do is developing tools to help animals in the wild, or understanding how animals in the wild are functioning, or to assess their function with animals under human care. And a lot of criticism we get is, you can't use animals under human care because they're not the same. But we've done studies, basically developed these tools with animals under human care, and we've shown that lung function and resting metabolic rate are the same in animals under human care, shallow diving dolphins and deep diving dolphins. Another criticism a lot of times you hear is, oh, the animals in the wild, they swim hundreds and hundreds of miles. So we actually worked with Sarasota Dolphin Research Project and Randy Wells' team to study animals in Bermuda. And I will let him tell the story about how far do they actually swim, and hopefully you can hear his voice. If I can get this to work.
Hi, I'm Randy Wells. I'm the director of the Chicago Zoological Society's Sarasota Dolphin Research Program. In 2016, we went off the coast of Bermuda and applied satellite-linked radio transmitters to 4 dolphins. We tracked these dolphins for the next 2 months, and we found that 3 of them remained around the island of Bermuda. Sometimes they were together, sometimes they separated. The 4th dolphin went north to a series of seamounts and then took us on a circumnavigation of Bermuda several hundred kilometers offshore. What this showed us was that these animals have quite varied patterns of movements, and as we think about conservation of these animals around Bermuda and those in the Atlantic Ocean basin in general, we need to be thinking very broadly about what measures can be done to help them.
So in short, I think that the use of animals under human care is critically important, especially as funding is dwindling, and a lot of these facilities do provide basically an invaluable resource for understanding limitations to these animals, the physiology of these animals, and also an ability to validating tools for studying animals in the wild as conscientiously possible as we can. So basically we can do this as non-invasive as possible. Okay, thank you very much.
Thank you, Andreas. Really love that stuff. I studied marmoset energetics for my doctorate, so I really gravitate towards your work in respirometry and energetics. So it's really fun stuff, and it's great to see how collections are being utilized in conjunction with studying the wild animals to hopefully improve the welfare and survivability for all of them. And kind of to that topic, we're going to shift gears a little bit now and kind of address some of the criticisms that many of you all have faced over your careers. I know I certainly have as an animal manager. And Our guests are Heather Hill and Kathleen Dudzinski. Heather is a professor of psychology at St. Mary's University in Texas, and Kathleen is the director of the Dolphin Communication Project, and she's also the managing editor of the journal Aquatic Mammals. So, ladies, just real quick before I let you go, in the interest of full disclosure, I am a minor contributor to this paper that you're going to discuss, but you two really did the lion's share of the work on this paper.
Well, thanks, Gray. And there's actually a team, and that's what we're going to talk about, but I got to share my screen. So hopefully I can do this and share my PowerPoint and then the presentation. So let's see. Hopefully you guys can see that. Everybody can see it?
Yep.
Good. Great. Okay. So thank you, Gray, for that introduction. And actually both Heather and I, in addition to the research science that we do, we both wear an editor cap. Heather is with the International Journal of Comparative Psychology, and I am, as Gray mentioned, with Aquatic Mammals. And so when the preprint for the Journal of Veterinary Behavior paper came out by Marino et al., we were concerned, I guess is the way you could phrase that, as were numerous of our colleagues. And our collaborators and colleagues include other research scientists, veterinarians. In fact, I was made aware of this paper by a veterinarian. And these are colleagues who do the science or work with the animals. We had a variety of different folks who participated in the response to this article. And what we wanted to talk about is how can you respond? As scientists, how can you put a rebuttal out there? Because there's a couple of paths that we can take to do that. And the main problem that we had with this particular paper that got out in the Journal of Veterinary Behavior is these folks once again put out misleading science, misleading details, poor evidence, in error evidence, and they muddied the waters by placing their personal beliefs on a particular topic into the peer review format. And for us, that is not acceptable in terms of how they did that. And so in order to respond to that, since it was in the peer review literature, and actually when we first saw it was a preprint, there's a couple of ways that you can do that. And one is to contact the editor. And we did. Our team here that responded to this paper, we contacted the editor twice, because one of the paths that you can take is to do a rebuttal in the same journal. But that is not the only path to a rebuttal. Heather, I'll let you comment.
Yeah, thanks again for the opportunity to participate in this podcast today. But we felt like we had received some criticism on a variety of social media indicating that the paths that we took specifically didn't follow the typical path that people were supposedly familiar with in terms of what do you do when bad science gets out and how do you address it. And so as Kathleen mentioned, we attempted to go about it the more traditional means. And when that didn't work out, we got creative with our thinking to figure out another way to do it. And what we decided to do today was really kind of walk through those traditional paths and that less traditional, or maybe the alternative paths, in which rebuttals to scientific papers have to be able to get out and be shared. And in our process of putting together today's portion of the talk, we realized a few things which I think are important for us to clarify to the general community. Shall we move forward?
So the traditional course, or the traditional path of doing a rebuttal, is more of a linear fashion, and it's to respond to a particular paper within the same journal, within the same journal, to provide evidence to why you don't agree, why you feel that the evidence is wrong. And usually that comes when you have a discussion or a conversation with a variety of colleagues to confirm whether you're the only one that has that view, or are there multiple individuals who have that view. And because that's what science, as Gray has pointed out previously, science comes from debate. That's part of it. Different individuals will collect data, or individuals may talk about the same data set, but depending on how you interpret it, depending on the statistics that you use, depending on your research question, you may have different interpretations or different views of what's going on. And that's part of science. Science is founded on alternative hypotheses that will follow a path either together or diverge to come together with a particular idea that's accepted by most of the community as we go forward. So that's that first step, is to discuss it, to determine whether your concerns are shared, or maybe if you're the only one that has that. But if your concerns are shared, then the next step in the linear process would be to contact the journal editor with those concerns. And as we indicated just a bit ago, we did that. We wrote to the editor within a month of the preprint being available and asked how we could make this, how could we rebut, how can we get this out? And we were suggested to write up our concerns. And we assumed that then it would be, put together as a linear rebuttal. Of course, we followed that path, and then we'll tell you what happened as we go forward. So you can submit to the same journal in this path, or you can submit to a different journal, depending on how you go forward. And so as we indicated, we did go to the first journal with this. And when we finally had our concerns outlined and the details written, we were declined and told that we could submit our concerns as a brand new research article, which was not appropriate because we didn't have new data. We were pointing out the issues and the concerns that we had in the original article. So this is just to sort of let you know the path that we chose was different because we had exhausted the linear path, which is what we're showing here. And so once you decide both of these routes, whether you go to the same journal or you go to a different journal, then you come to your options for submission. You can have a commentary about the paper comment. You can have a letter to the editor, and usually that comes with an exchange between the concerned authors of the rebuttal to the editor. And you can also have a new article with new data that presents different facts or details. And to point this out, this particular path, the sequential path between communication with an editor and your rebuttal paper, et cetera, can take 6 months to 1 to 2 years. It is a longer process because you don't typically have a rebuttal in the same issue as the original paper. So do you want to comment on anything here, Heather?
No, I think we can, that's a nice segue to move us into what do you do in the place of being able to follow that sequential path.
Right.
So sometimes, I'll take it.
Yep.
Sometimes we have a planned debate in a single issue for a particular journal. So for example, Animal Behavior and Cognition has selected a paper that they feel will provide a controversial topic. And then they send that paper out either to experts in the field or to others who would be able to comment on it in an objective and a scientific manner. And once those papers come back, then the whole debate is published at the same time. So it gives an opportunity for alternative views. It could be an opinion or a commentary. It could be a different study that either counters or supports the controversial paper that was published. And so this is one avenue that I think has occurred maybe a little more frequently as things have become not necessarily collaborative, but in an opportunity to try to present two sides of or commentary of controversial topics. Another option that we can do is, and this is ultimately kind of where the paper that we chose to put in and another paper that we're going to hear about did, was to present the differing views in different articles that are published in different journals. And again, this was something that was suggested as being a not typical and unprofessional pathway. But as we started taking a look at how our rebuttals and papers that are counter to certain ideas presented, we found that this is a pretty typical path too. Mm-hmm. It's not unusual to see that you'll find multiple papers from the same or different authors presenting evidence for their interpretation of a controversial topic within a particular journal or across multiple journals. And Kathleen has a really great way of explaining this.
Well, one good example and a huge debate over time in the marine mammal industry, specifically with dolphins, was the signature whistle debate, which started in the mid 60s and all the way through until the late 90s, when there was debate over, basically, if I could take up 3 hours talking about that debate, but there were different viewpoints on what the functional interpretation of signature whistles was. And these different papers by same teams of authors and different teams of authors and scientists collecting data covered a variety of different interpretations. And they were published in a variety of different venues, not just different articles and journals, but different books as well. So you can have a variety of different topics across a variety of different platforms. Another example, besides the signature whistles, is cetacean sleep. And this is where you could potentially have everything collected in one journal, but over time. And early on, there was an original article in Nature which talked about cetacean sleep, and that came a bit under fire. And so what Nature did was collect all of the different rebuttal articles that were submitted and publish them at the same time together. So those rebuttal pieces were published after the original article, but they were put together collectively and then linked back to the original article. So with technology now, we can actually link a variety of different things where, previously you'd have to go in and find those hard copy papers. But the idea is that there's a variety of different ways to get a rebuttal out into the public. So, and what's interesting about that as we go forward is, okay, well, what's the impact of the original article versus the rebuttal? And this is where it gets, for me as an editor and as a scientist, a little scary. I'll let Heather take it from here, though.
Yeah, so, and I have to agree with Kathleen on this. We did a little digging to see what happens to the original paper in terms of publications and citations, and what happens to the rebuttals that come out about it. And this was a paper that was done in 2011 on aquatic and fisheries. And if you'll notice, what they found in their paper was that the original paper was cited 17 times more than the rebuttals that were presented on this set of data that they were looking for. And more importantly, 95% of the readers accepted the original paper without critique. And when we start putting this into perspective, good quality science is absolutely necessary on the first go around, clearly. And when we start putting personal beliefs in with our peer review process, and we are stepping outside of the objectivity that the peer reviews are supposed to be providing, and papers like the one that was rebutted get out, unfortunately, our rebuttals may not have nearly, if this 2011 paper is correct, as much of an impact as the original paper is, because people aren't taking the time to look for the full scope of resources immediately, as we've seen with other things. So when we start thinking about this whole process from a journal perspective, from an editor's perspective, and even from a scientist or researcher perspective, it's really, really, really critical that we get our evidence out there correctly the first time, and that it is done objectively.
Yeah. And I think that's our last slide. The only thing that I would add is there is no place for personal belief in the peer review process. Personal belief will inform science. Personal belief will inform the peer review process, but it should not be what a review or what a paper is based on.
Thank you for that, ladies. It was fantastic. Our final panelist today is Jason Bruck, and he's going to pick up with some of those themes you just mentioned. Jason is the assistant professor of biology at the Stephen F. Austin State University, and he is going to treat this Moreno paper as a case study. And I should mention that one of his co-authors is our other panelist, Kelly Jaakkola. Jason, the floor is yours.
Okay, thank you. So first I want to acknowledge my co-authors on this commentary, Kelly Jaakkola from the Dolphin Research Center, Richard Connor from UMass Dartmouth, Stephen H. Montgomery from the University of Bristol, and Stephanie King, also from the University of Bristol. So rather than write a rebuttal to Marino et al. 2019, we felt that the paper was egregious enough to warrant a commentary using it as a case study for the larger phenomena of trying to pass off animal rights opinion pieces as legitimate scientific discourse. I think many of us were flabbergasted that this made it through the peer review process, so this seemed like the poster child for the encroachment of op-ed level material into our scientific journals. Our approach was not to take a stance on orcas in captivity because that wasn't the issue to us. The issue was bad science. As such, we had collaborating authors who held different views on orca captivity. And we think in this case that it helped strengthen the critique, as this is not about any agenda other than the propagation of good science, as the previous paper was also as well. As Marino et al. 2019 is nothing more than a series of ideas without much in the way of legitimate scientific backing, we felt that this paper should not be considered as evidence of orca stress when it comes to pushing forward anti-captivity legislation. Welfare policy and laws must be based on good, legitimate scientific inquiry. Our paper and Dudzinski et al. 2020 make it harder for interested parties to claim they have evidence of harmful stress effects in orcas when they do not. So as such, we use Marino et al. 2019 as a cautionary tale and as a tool to promote good science, not just for the sake of science, but for the effect science has on policy and animal welfare as a whole. So while Marino et al. 2019 suffers from many egregious problems, some of the most notable stem from its misleading use of words, its absolutely shameful misrepresentations of previous literature, and its broadly prescriptive recommendations based on poor argumentation and, in an applied sense, concerns around the author's use of the paper in the media and legislative testimony as evidence of harmful stress effects in orcas without actual data supporting that conclusion. So to give only a sampling of the offenses, here we see the use of the word why to imply that captive orcas suffer from chronic stress without any evidence given in the paper to support that conclusion. And for those of you listening on the podcast, the quote is, Marino et al. Notes that previous papers have not offered an explanation for why captive orcas suffer chronic stress, implying that of course they suffer chronic stress. Why wouldn't they? You have no data to suggest that. Okay. Just as numerous in the paper are incidences of misleading summations of others' research. Here, Marino et al. Gives mean life expectancies for male and female orcas, references two papers from previous authors. When you investigate what those papers actually said, you find out that the ages were in fact ranges, and that Marino et al. 2019 selectively only took the upper ranges of those ages to make the argument seem more convincing. This is very much scientific malpractice. So, for, again, those of you listening on the podcast, the quote is, we conclude that orcas are poor candidates for the maintenance of captivity and suggest that a radical shift is required in their treatment to meet their complex needs. Without evidence, Marino et al. 2019 is making conclusions and telling people what to do. This is overtly broad and not at all a natural conclusion based on the actual scientific evidence they have put forward, especially as they rely on a human PTSD expert to draw unwarranted comparisons between the minds of two species separated by about 100 million years of evolution. So again, for those of you listening to the podcast, I'm going to read you some quotes from Lori Marino taken from Nat Geo. There is abundant, unquestionable evidence for personhood in animals. Lori Marino, 2014, Nat Geo. It is really not a matter of making the tanks a little bit bigger or deeper or forcing them to perform more naturalistic behaviors. The whole enterprise of keeping cetaceans for entertainment and or research just doesn't work, and the scientific data are abundantly clear on this issue. There is no room for interpretation or debate at this point in time. Cetaceans lead shorter, more stressful lives in marine parks and aquariums than their wild counterparts. Lori Marino, Nat Geo, 2017. Science does not start with an answer. It is a process, and you are not allowed to skip to what you think is the end and then call off debate. That is not how science or scientific consensus building works. The pushback against Marino et al. 2019 is not motivated by a pro-captivity agenda. It's motivated by a good science agenda. Marino has been for years quoted in publications calling for an end to the discussion when we barely have any data. This isn't climate change where the science is well grounded. We don't have basal cortisol levels that we can easily compare between wild and free-living populations of orcas. We don't have complete longevity data for wild killer whales, especially when we count captive whales from birth, while counting wild whales after 6 months, fundamentally ignoring stillbirths of wild orcas. Closing off debate on issues of captive stress may serve the purposes of the animal rights movement, but it does the whales and other species subject to this faux science no good. And that's that.
Fantastic, ladies and gentlemen. Really wonderful stuff. And when we come back after the break, I want to open things up a little bit and let you have an opportunity to discuss amongst your peers here what thoughts you might have about your own work and the work of others. So we'll come back after the break and stay with us.
In order to ensure continuity of care to our animal families, effective communication is key. Cloud-based animal care software allows team members to upload documents, photos, and instructional videos to daily husbandry reports. We at Animal Care Software are very excited to be working with Dr. Isabella Clegg on developing a tool to manage animal welfare. Working with her customizable templates, Dr. Clegg was able to create an all-animal individual welfare template. The template contains a selected group of welfare measures that can be applied to any animal species. The goal is that facilities with animals in human care will be able to collect data based on the 5 domains and allow them to be at the cutting edge of welfare research. In the future, we hope that the data collected will contribute to defining factors that accurately measure good welfare for all animals in human care. Register at animalcaresoftware.com and enter the coupon code Zoologic for a free trial. Be well, colleague.
Well, I want to welcome everybody back to Zoologic. We are with our panel, Kelly, Kevin, Andreas, Heather, Kathleen, and Jason. Thank you for your presentations and trying to correct the narrative about marine mammals, those in our care and those in the wild. And so I wanted to open it up a little bit for you to discuss your overall thoughts about this story that you've all woven today, any concerns you have going forward, and maybe what is the direction for us as far as getting more science, but also correcting the narrative. Anyone want to start?
I guess we all jump in. I guess the one comment I'd start with is I remember in graduate school, my advisor and my committee telling me how important peer review was, and to expect to have critique and to expect that my first submission on any paper wouldn't be accepted, that I would need to revise and resubmit because my perspective is one perspective. But there are several other individuals out there who might be looking at the same data or who might be looking at something completely different and bring a new perspective in. And I was taught that your papers can only get better with that critique, with that constructive criticism and that critique. Because when you're writing something and you're working on something, you're so close to it that you get blinders on. You can't see something else that might impact that. And so have I gotten reviews that sting? Yep. Have I gotten reviews that were great in some aspects, and then in others I had to work a little harder? Yep. And yeah, the ones that sting, I might take a day or two and have a little, pity pot session and maybe, get frustrated. But then I come back to it and I'm like, okay, well, how can I make this better? How can I go forward? And I think that process is something that younger scientists need to know that it's there and it's useful. And I think also, in addition to scientists having to make sure that they get the peer review out, I think what we need to do is work on making sure that our sound bites for the general public, which also includes all the social media, are accurate and engaging, so that people listen to those sound bites more than the other stuff that gets put out there. And that, I think, is a challenge.
Well, and I think you've addressed two things that are uncomfortable for those various stakeholder groups. One is the idea that my work needs to be challenged and critiqued and edited and revised and revised and revised, right? We've all written things that we thought in a moment might have been the greatest sentence ever constructed, and then you come back a week later and like, nah, that's not so good. And so I think that is an art form that is not well valued these days. I mean, if you look at the current situation with COVID in the US, what are we doing now? We are criticizing scientists for making their best guess from months ago.
Yep.
And treating them as if they're working against us, there's some sort of deep state plot, when in fact, that's how science works. We put forth an idea, we test it, and we make modifications to our understanding as we go forward. So that's one thing. I think there's a misconception of how science works, and that beating something up is actually good for it. And then the other thing I think is that I don't know, I've lost my train of thought. Someone else take it from there.
Okay,
I think. Go ahead.
I'm about to toss it to you, Jason. Anyway, so let me do this, because based on what you were just saying, Gray, I wanted to highlight something that Jason had said, which I hadn't really thought about before, although I should have, because I've heard them say it many times, which is this idea of saying no more debate is necessary. We've got all the data. You know, I don't know what science field ever in life says we've got all the data, we're done. That's just not the way it is. And so, and I have heard them say that, and I think it's worth highlighting how bizarre that is.
How's that cold fusion working out for everybody?
Yeah.
That's not science. That's religion.
Yeah.
Yeah, and
I'm sorry, go.
And I think one of the things that we can kind of take away from the process of science, I mean, it starts with observations, right? And then you take those observations and you go on and you generate hypotheses. And then you test those hypotheses. And then from there, if you get enough people who are coming up and agreeing with these ideas that you keep generating, and there's a lot of reinforcement of those ideas, then those hypotheses build into theory. And then from there, the theory is always still questioned. There are tons of evolutionary biologists who are still making their careers testing evolution every day. Okay, so even on things that biologists, consider very settled science, there's still constant challenge to that. And so, no, we don't shut down the debate. We don't say, okay, it's all over, it's all done. Now, if somebody comes up with the ultimate paper that challenges evolution or climate change or the theory of gravity, okay, if somebody's got a really good paper that challenges that gravity's a thing, that paper is going to do really well. It's going to go into Nature. It's going to go into Science, premier, eminent journals. There is great incentive for scientists to challenge each other. That's how the scientific process works. So the idea that when we challenge Moreno et al. 2019, that we aren't allowed to do that, or that is something that must be done in a very specific way, or it is not acceptable, that's a fraud, that's a joke, that's a lie. Science can challenge in all different ways. As was brought up in Kathleen and Heather's talk, when the signature whistle debate was raging, I mean, there were titles of things, the fallacy of signature whistles. These were not, very gentle titles to each other. Right. They were going back and forth on it, but it was through multiple journals. It was not one of those things where it was like, you're when you're critiquing someone, when you're critiquing them, they don't get to pick how you critique them.
Well, just to jump in, Jason, what you're saying, that's in the scientific journal, but some of those debates rage at conferences. Yeah. I mean, and that's where it can get really heated. I mean, you can get heated in the written word in a journal, you can go back and forth. When you got people standing in front of each other at a conference and they're calling each other names just about, that's another version of rebutting your idea or exchanging ideas that are contrary to one another. And the whole idea behind what we do as scientists is to gather data to either refute or support a hypothesis. And at least in the behavior sciences, I'm not speaking biochemistry or physics, You're never going to prove something 100% right all the time. Because as soon as you say that, as soon as you think you've got something that's 100% right, you're going to have that exception to the rule.
Yeah.
And
proofs are a math thing.
Well,
they're not a science thing.
You're also going to close off your own mind to thinking about what else is possible.
Yeah.
What other solutions are existing out there? Kevin, you wanted to say something a minute ago. Go ahead.
Oh, I was just going to say that in the late 1600s, people thought science was done when Sir Isaac Newton published the Principia, right?
Yeah.
Apparently it wasn't done. There was a little bit more to figure out. And I think that's always going to be the case. So there's a long history of people wanting to just say, we're done now. We'll live with what we got. And that is not the way.
I love to go back and read some of the debates from the classical and the quantum physicists of the early 20th century. I mean, it's knockdown, drag out kind of battles in print. I'm sure they had wonderful conversations over schnapps or whiskey or whatever at meetings, but it was truly a knockdown, drag out fight to discard the old theories or limit their application to classical conditions and accept this bizarre world of quantum mechanics. So, Andreas, you also had something to say.
I'm sort of the other spectrum, that I think that the rebuttals are important, but when the rebuttal is to a paper that has disproven another paper, it sort of becomes a drawn out process. And I think that they are important. They're super important to continue this. What I find disturbing is, if I understand it correctly, how it was handled, that you couldn't do a rebuttal in the journal where this was published. And I think that is, especially if this is a well-known and well-reputed journal, that is worrisome. Why is that happening? Because it is, I totally agree with this discussion that, yes, it is hurtful when someone disagrees with you, but it is part of the process. 90% of the time we're wrong anyway, and I think it's just accept that. That if you don't get that message when you're out of graduate school, you're soon going to get it as a postdoc. And if you don't get it at the end of your postdoc, I think that you should go back to graduate school, because this is, you're doing the best you can. And I think that most of us do the best we can. And I say most of us that are doing science, and accepting that you're wrong and then admitting that you're wrong. I rather admit that, oops, I was wrong, than someone else saying it. And I think it's an important process.
But is this not, sorry, go ahead.
Well, I was just going to add from an editorial standpoint, as an editor of a journal, and Kathleen and I had this discussion the other day about the importance of being able to maintain objectivity when you are an editor of a journal, because you may not believe or agree with the stuff that comes through your system, but when I mean, so you're not passing judgment.
You shouldn't pass
making
judgment.
a decision about a paper. No, right. So getting that information from an expert person, or two or three or four, depending on the comments that come back. And it is the editor's responsibility to be able to then judge, make a decision of what's reasonable in terms of this. Are we getting objective reviews, or are we getting reviews that are intertwined with personal beliefs and
or personalities?
Personalities or arguments that are presenting, in the review itself, and that as an editor responsibility has, hugely responsible. I mean, I am so glad I didn't become a clinical psychologist, because the idea of managing people's behavior and worrying about them was so overwhelming. So, okay, let's go be an editor for a journal. It's not a big journal, it's not an impactful journal, but let's go make an impact in that way, where we can make some different decisions. But it really brings to home the importance of, when you should have a process in place, you should have multiple processes in place for situations such as the one that we just went through. And an editor's ultimate responsibility is to be objectivity. I mean, that they have to be objective.
And we can argue about the process. But at the end of the day, it's still about the content, right? Jason, you wanted to say something.
Yeah, and I think what we are talking about the idea that, someone publishes maybe some data, there's some things they didn't think about, there's caveats there, and there's a challenge to those data, and then there's a reevaluation of what those hypotheses mean, or the support of those hypotheses mean. This is different. This is something where they put out something very specific, and they did some egregious things in doing so. The misuse of those citations alone should have immediately called for the rejection of that paper.
Correct.
Mm-hmm. Correct.
When you
Which was
actually
requested multiple times.
Right.
Yep.
When you go through and actually, and this is the hard part, this is that Brandolini's principle of BS asymmetry, where the amount of effort that it takes to dispel a lie is exponentially more than to be able to generate the lie in itself. They didn't count on people going through, finding all those references, checking what those references actually said, and then writing up the actual statements by those original scientists. Those original scientists are disserviced by the misuse of their research, and that can only be done knowingly. Well, you can't do that unknowingly, unless you didn't read the paper.
You can't do that 100 times.
Well, and this may be the most egregious example of it in recent memory, but it goes back to one of the papers that Kevin cited, which is this is our goal, this is our stated goal, but oh, by the way, we're going to make this invalid comparison, and aren't we great because we're in a well-regarded journal, and that message, that narrative has moved on, moved forward, and believed by so many people.
When you get that's the thing, is when you get bits like that, when you have those sideways narratives slipped in, that is also, in my view, an editor's responsibility.
Right.
Because the editor allowed that to go through. I've had numerous papers that come in where it's like, I'm sorry, and this is in the review stage, not when it's been accepted, but this is in the review stage of, I'm sorry, your conclusions here, you don't have any data in this paper to support it. So why you can't say this? So if you're gonna, if there's various points that are put in there, I mean, you can't let that through. I mean, everything else can be fine, but if you have this egregious statement, it's like, no, as an editor, I'm sorry. There's certain things that if you don't have the data to say it, it shouldn't be in there. And that's part of the process.
Andreas, you raised your hand.
Why isn't this retracted then? Why doesn't the journal retract it?
Exactly.
Because now you have two publications with point-by-point limitations to this study and how they misused whatever they've said. I mean, this is a case for rejection. Or for
Andreas,
retraction.
I would have to, I really don't feel it's appropriate for me to say anything more except to say, contact that editor and you will probably get the same pointed responses that I got when I sent them in. And I'm not gonna,
Well, let me do it for you, because I can get away with that. It was basically a stonewall. There was no real attention to the content of our raised concerns. It was all about following their process, which only led you down that pathway of a peer-reviewed paper, a standalone paper, as you guys both pointed out. Mm-hmm. And so there was almost a dismissal, not just from the chief editor, but from someone on her board, of even acknowledging that there might have been fault or a faulty process during the review. And that was deeply troubling to me, because there was no openness to even consider that maybe the journal had made a mistake and might want to at least issue a statement about it.
Well, and the problem, to add to that, for me, now calls into question for me other articles published in that journal. Because if this is the process that they're going to do, and this is how they responded when we had a concern, and it wasn't just me raising my hand and saying, hey, I've got a problem with this. We had a list, not even all the folks that were on the authorship list who were on the emails that we sent to the editor. And it was a complete dismissal.
So let me ask you all this question, because I want to pivot a little bit, because I thought of my second comment that I want to make earlier on, and that is being put in the uncomfortable position of, for scientists to do more PR, to be more media savvy and aware and active. That's a role that I don't think anyone in graduate school, at least when I was in graduate school, was taught. In fact, we were taught to let the data speak for itself, the papers speak for themselves, and all will be well. It'll all kind of boil out and truth shall prevail. Well, we don't live in that world anymore. So as scientists, many of you have been called upon to speak to CNN or wherever, the Associated Press, wherever. What do you make of that? And what kind of challenge does that add to your life when you just want to go out there and study wild animals or animals living in zoos and aquariums? Anyone?
Gray, when I finished, sorry, I saw Andrea's hands, but I had already started.
No, mine is short. I want to be Jason Bruck. That's all.
I want Jason Bruck's hair, okay?
No comment. When I finished in graduate school, I chose not to go down for my postdoc and the others, the typical academic route, because at that time in the mid 90s, I was not allowed to do stuff with the public, to do stuff with aquariums, to do stuff with, non-ivory tower groups. They didn't want that. And now a lot of the students that are graduating need to have some form of outreach or broader impact of their research. So it's not just the peer review and it's not just in the ivory tower, but that has come as a request. And I'm not in an academic situation, but talking with my colleagues like Heather and Jason and others, I don't think those are courses that are being given to the students. So I think they're being required to have this ability to talk to the public, but they're not being given the tools. And I was fortunate enough early on in my career that I had media training. I was asked to be a part of a couple programs, and I was given that training and told, consider these points, don't do a negative, don't answer a question with a negative, try to keep your answers short, find the sound bites. But if we don't teach the kids that, or any of the scientists are out there, just some basics, then we're not gonna get our impact, or we're not gonna be felt in terms of what our messages are or impact, because we get convoluted in how we describe the science.
Kelly, you wanted to say something.
Yeah, I did. I kind of want to change your question a little bit. Because the way that I heard your question was, how much of a problem is this for you? And okay, that's fine, but that's sort of like, to me, I always talk about, well, that's like saying, well, how much of a problem is gravity for you? It doesn't matter. Gravity exists. That's the way it is. That's the world we live in. And the world we live in now, we need scientists to tell their own stories. And so instead of how is it impacting and inconveniencing us, I think maybe a more productive discussion would be, how can we not just as scientists get better at it, because that's important, but how can we find the venues to tell our stories?
Mm-hmm.
I know that is a frustration point for you, Jason. We've talked about it in the past where, the very authors that we're discussing today, some of them are the knee-jerk people that people pick up on speed dial at CNN and Fox, wherever, and they're not calling Kelly Jaakkola, Jason Bruck, Heather, Andreas.
Yeah, I don't think they're sitting there with like citation indices trying to figure out who are the best published scientists in the field when they're trying to get a quote for a paper. I mean, honestly, the things I would get called for would be stuff that was not even in my wheelhouse. And I'd flat out tell them, I have no idea what this is. This is not, I don't know where you got my name for this, but this has nothing to do with me. And then on the stuff where it'd be like, yeah, that's something I should make a comment on, you see one of those authors from Marino et al. 2019 being referenced. And it's like, you've never worked with that animal. You've never done anything with that animal. You have no idea what this is. You've never published in that. So the reality of this is, how does one move the needle as a scientist? And I think there's a couple of ways. So in 2013, I get my PhD. 2013 is also the year Blackfish comes out. So it was almost a baptismal by fire, because that was raging. And I would go online and I would see the spreading of blackfish as if it was factual truth. And that's where I would start to make my point, not necessarily as a scientist, but as a concerned citizen. And that's a really hard place for somebody who's spent 12 years getting a PhD now has to deal with, because when you're debating someone on a Facebook who just watched a documentary and thinks they're an expert, it doesn't matter that I have 12 years. We're now effectively leveled out. That is an equal form. That is the opposite of the meritocracy. So in this debate, you end up in this position where you are forced to use facts and reason, not your degree or your list of publications. They don't care. Nobody cares. You have to continuously provide evidence. And again, you're not changing the mind of the person who's been completely convinced by blackfish. You are influencing the other people who are reading that debate. And one of the things that you will always see remarked on there by spectators is, well, yeah, you watched a documentary, but he's citing papers in science and research. So I'm going to listen to what that is. And that's where it got started. And it used to be just me in those rooms against 20, 30 people. Now when I go in to see this stuff, I feel like, oh, I don't have to really participate. Somebody else has already got it. People are already in there, and they're citing the papers that I used to put in there. Simon et al. 2009, the story of Keiko's failed release in a peer-reviewed journal. You see other people citing that in there with the links. It's fantastic. And so that's another way to do that. That doesn't involve me being, on CNN or on some of these other things. It's really at the kind of ground level. And I mean, it can be difficult work. It's definitely work you're not going to get any credit for doing. But at some level, it is effective because you really are getting directly to the people who have been influenced by the mockumentaries.
I will say this, when a media outlet does call, even if it's outside your wheelhouse, it's really important, I think, to build that relationship as being that go-to person where you can provide some answers or some direction or some citations or other colleagues that might be better suited to that conversation, because you don't get those invitations very often. And the good news is, once you've established yourself as a credible guest, spokesperson on whatever topic it may be, they're going to come back to you and you're going to build that rapport. And that, I think, is what's working against us in the case of, say, Naomi or Lori, is because they're kind of a known quantity. They're always going to take whatever press they get. And I realize I'm kind of owning myself by saying that. But so to the extent possible, when you get that call or that text or that email, do what you can to make it happen. Even if you establish at the beginning, look, I'm not this type of scientist, but I know from experience that X, Y, and Z happens. That often is effective and often enough to satisfy those producers to put you on the air or record you or whatever.
The other thing, I'm sorry.
No, go ahead.
I was going to say that the other thing I think that is working against us, or at least working for, say, the Naomis and the Loris of the world, is what counts as news when you're talking about, animals, and specifically in this debate about how animals are doing in marine mammal facilities. If you say such and such animal has this problem, that problem, is being mistreated, whatever it is, that's news in and of itself. That's news. For me to say, hey, our dolphins are doing great, that's not news, right? Even if that's the truth, that's not a news story. And so I think we need to get more creative and better at finding ways to tell that story without highlighting the other side, because that's what often happens. Is the only time we say, hey, our dolphins or whatever animals we're working with are doing great is if someone has said that they're not. And I think we need to find ways to highlight that in and of itself.
And that's something, I mean, I don't watch news except maybe once a week so I can get the weather for what's going on, because that's basically our culture, at least in the United States. I can't say, anywhere else, but nobody wants to hear good news. They don't want, I mean, I would watch the news if there was good news on the news, But people, they want reality TV. I am floored by the amount of different reality TV programs that are out there, and everybody has a problem. There's always drama. There's always some issue. When did that happen? Because that's across the board. It's not just dolphins, it's everything. And it's, you know, that's the distressing part of it. It's kind of like the golden rule. I mean, I went to kindergarten. You know, you do unto others as you've had done unto yourself. So it's hard for me when I see something that's so egregious, like this paper, and so contrary to what I understand as the process for getting good science out. And I agree with what Jason said, is I don't see this as being an oops, made a mistake. I see this as we want this view and this opinion out, and we're going to do anything we can to get it out.
Well, and I think to your point that science has changed in the sense that we have mass media, we have all these different platforms. And so some scientists are comfortable taking that mantle and saying, this isn't right. It's not right for X, Y, and Z reasons. And here's what we think is happening in the wild or in zoos and aquariums. And that's still a relatively new, I think, role for people like yourselves who are already busy grading papers, teaching lecture, finding funding, and once in a while trying to get out in the field to collect some data. So let me ask you this, because we're running up against time here. Knowing what we know and correcting the narrative as you each do in your own ways, in your classrooms, in your meetings, online, and in this podcast, how do we tell those better stories? And what sort of gaps do you see in the data right now that you think we all should be looking at to help us correct the narrative? What other, Kelly's often reminding me of the gaps in the data. So for each of you, what sort of gaps do you see that are most immediate that we try to fill and answer?
All right, I'll take that one, at least to start with. With life expectancy in particular, when we did our paper, we have now looked at the data in the US from 1974 through 2012, because that's where the data got a little bit squirrely after that. So I would love to be able to get data from different places, both in human care and in the wild. We currently, like I said, have 3 populations of dolphins from a very specific time periods where we have that data for wild dolphins. And so in the absence of having that data, people just say, well, the data that you're looking at was from which is true for 2 of our populations, were from dolphins who were compromised. That was true for 2 of our populations. I showed that, not for the 3rd one. But they say, so you should be looking at these other populations. Great, someone who's studying those populations, please get us those data. I think that's absolutely important and relevant. But until we find that population of dolphins in Shangri-La, all we can do is look at the data that we've got. So that's what we do.
Well, let me ask you and Kevin both this question, and I don't want to open a can of worms. This may be cause for another episode here, but do we need to look at data from a historical standpoint, given that in the past, the wild was kind of seen as the baseline, right? The wild is perfect. This is how things are, and captivity is the anomaly, and clearly bad. That was the narrative. Well, now we're seeing that wild populations, to your point, Kelly, are in big trouble. So do we need to also put an asterisk by old papers, as well as the new ones you want to do, by saying this was collected back when we didn't have so many PCBs in the water, or this is, I mean, do we have to kind of now make the case that the wild is no longer a static baseline, but it is also changing over time, and that also implicates our interpretations? Kevin.
A couple comments. Absolutely. We know there's temporal changes in how we care for animals. There are temporal changes in the environment, and we have to start tracking that to see if it is indeed affecting things. And my second point I want to get out is looking at how long animals live is so one-dimensional. How do they live? What information can we be collecting? What are the things that actually affect, I mean, transport mortality, that comes up all the time, right? Is transporting animals good for them because it gives them novel social groupings, or is it stressful? Is it initially stressful and then it's beneficial? There's just so many things we need to be looking at that go beyond, did it die?
Well, and Andreas, one of the questions you look at is you're comparing inshore, nearshore dolphins and their habitats, which are relatively shallow, to Bermuda dolphins, which are deep divers. And you're trying to, your data has indicated that there's really not a whole lot of difference about them, unless I misinterpreted it.
No, that's absolutely correct. And I think that these are the things, it's an easy selling point to say, well, it's not the same living here than living there. And I mean, I buy that. I would buy that if I didn't work in this field. And my mom buys it, unless I tell her, please listen to me. But it's, unless you have the data, no one can come and tell me, well, the lung function can't be the same because they don't live in the, well, it is. Here is the data. Well, you go out and collect the other data and tell me different then. And I think that it is an easy selling point. It's an easy selling point to say that they live, this is a concrete jail. Okay, well, you then get me the objective data to do this. Life is different, yes, but is it worse? What does a dolphin need? And I think Kathleen is the expert on this. What does a dolphin need? Because she has made the comparison between animals in human care and wild dolphins, and the behavior is not different. And now I'm quoting you, Kathleen, but
you're right.
But these are the things, this is the data. So with technology, we can start to look at this in fine scale. And this is what we're doing with turtles. And then we're hoping to do this in dolphins. And people have started doing this. So you can look at behavioral changes in animals when they're happy, when they're sad. And you can start to look at this in fine scale. And good aquariums, like good restaurants, will change their behaviors if things are not good. Bad aquariums, I think we need to push them out. That look, you shouldn't have marine mammals in human care. You should have maybe cockroaches. And I think that is the change that needs to happen, that these facilities that do a good job, that are honest about what they want to do and provide as an educational facility, as a research facility, we really need to protect them, just like we need to protect animals that are endangered, because they provide such an important and crucial resource
comparison
for us.
Group.
Yeah. Mm-hmm. And that, to add to that, Gray, based on what Andreas said, one of the key things, whether you're talking about what Kevin and Kelly have presented or what any of us have presented, especially when you're looking at the research and the data and the gaps, when we do our comparisons of dolphins in different settings, in managed care, in the wild, in other areas, whether it's man-made pool or a natural lagoon, we're following exactly the same set of assumptions and the same protocol to collect our data and then to analyze our data. And a lot of the literature, the early literature that was comparing captive and wild dolphins, were pulling studies that had different assumptions and different backgrounds and different details. And then they were comparing them. And that's apples to oranges. That's not apples to apples. And that's, yes, I've, at this point in the research that I do, and Heather is right there with me, I don't even consider the question of captive versus wild anymore, because I have a decade of data showing there's really no difference. And that's from dolphins in natural lagoons, two groups of dolphins in the wild, and from dolphins in man-made pools. So, for me, that's not even a question. Where I'm going next is founded in a similar comparison with the assumptions. And that's looking at social animal behavior, looking at dolphins compared to primates, compared to an avian species like ravens. And what we've learned recently, and this was something that Heather and another colleague, Maria Botera, and I did, is generally out there, when you see people comparing dolphins and chimps or dolphins and other social animals, they're saying, yeah, they're really the same. They do all this. But when you start looking at the nitty gritty of the behaviors and you want to do a direct comparison, they're not. They're not. The developmental differences when you're looking at a primate infant versus a dolphin infant, they don't match one to one, And so where that popular literature came of saying, yeah, dolphins are swimming apes. No, they have some similarities because they're social animals. But when you start to get down into it and you want to do those direct comparisons, you got to step back because the assumptions for how those data were collected were different. And that's a gap in my view.
You might want to let Marino and I'll know that, Kathleen. Jason, final thought?
Yeah, I wanted to go back to what Andreas said about, kind of the good facilities, the bad facilities. That's a nuanced argument, right? When you have papers like Marino et al. 2019, that completely obliterates all nuance.
Yeah.
We can't have the right kinds of conversations about welfare when the answers are all or nothing. It puts them in an anti-captivity camp. It puts us in a pro-captive camp. That's not what the actual discussion is. The discussion is, pro-responsible management. What does that look like? That's what we're advocating, okay? That doesn't necessarily mean taking them from the pools they live in and dumping them out in the wild and saying, enjoy the PCBs, okay? So what we're talking about is we'd like to have a nuanced argument. We'd like to have an argument that takes into account multiple factors. And that doesn't necessarily work well in sound bites because it's complicated, right? It's complicated. And so that's another disservice that we have to work through is saying, okay, we want to serve these animals better by having the nuanced conversation about what is good, what is bad, and how do we fix it if it is bad, okay? This type of paper from Marino et al. 2019, that prevents that conversation because it puts people in a you're with us or against us camp. And as long as we're to that kind of thinking, we're not going to progress in the welfare the way we want to through the scientific literature. Zoos and aquariums are still doing great work progressing their own welfare, but it's not necessarily happening in the literature the same way with these types of papers coming out.
And we're going to have to leave it there, but the biggest loser in all this, of course, are the wild populations, right? Because they can't take the drone data from Jason Bruck or the population data from Kevin and Kelly or the communication data from you, Kathleen and Heather, or the dive physiology work that you're doing in the field and in managed facilities, Andreas. And so the ultimate loser are future generations of marine mammals and human beings as well. So on behalf of myself, I really appreciate all the work that you do. I wish we could spend all day talking about this. I know we could. We're just getting ramped up. But I really want to thank you for taking a proactive stance and promoting the work that you've done and calling out some not so good work that others have done. And we hope to have you back in the future. And I just want to say, this is probably the first video version of a Zoologic podcast ever. So you've all been my test subject. You've all done really, really well. I appreciate that. And we absolutely thank you for joining us on Zoologic.
Thanks, Greg.
Great.
Thank you. Pleasure.
Can I just end with something?
You always.
I don't agree with science is boring. I think that we need to change the narrative. I think if you ever see a kid in a zoo, and I'm sure you've seen a lot of them, look at their eyes. And we need to tell better stories, and we need to communicate science. And I think that, especially when it comes to SMM, the Society for Marine Mammalogy, we need to be there. We need to teach science communication, and we need to change that narrative. And I think that is one way. And the other one that Jason was proposing is we need to change the narrative of what is actually welfare, 40 orcas in human care versus 300,000 marine mammals asphyxiating in fish nets.
And I just want to add one comment with that. Sometimes that information is not sexy. It's not fun. It's the baseline information.
It can be.
Well, no, I think I
have a really sexy veterinarian, and I ask him to take off his shirt. All fixed.
Time. Oh, that's it.
Bye.
No, but I think it can be, and I think we need to learn how to sex it up.
Yeah, and do it in a way that is true to your behavior, your data, your methodologies, your professions, and I think you've all done that today. The first half of this podcast, you each presented a compelling story for what is and what isn't truthful to our best of our ability. And that's the kind of storytelling that is impactful and motivating, inspiring, to your point, Andreas. And again, thank you all for what you do. And it's a pleasure to know you each and to see the work that you do on behalf of animal welfare and human welfare. So thank you.
Thanks, Gray.
Thanks, Gray.
Thank you.
Thanks.
And with that, I'm going to end the call. You guys are fantastic. I will send out links. Really good stuff today. And I know we could talk about this forever. And I appreciate you guys so much. I really do. Thank you.
Thanks.
Thanks,
Alfred.
Gray.
Thank you.
Bye.
Thank you, guys.
Bye.
Again, everybody. Stay healthy.
Same.